So guys, let's start create our environment here. So to do that, I use Conda, Anaconda prompt. So I will access my documents here, my folder dev. We'll create a new folder, Petshop Copilot. I will access this folder, and I'm already inside an environment called base here, but I will create conda create name patch copilot. I will use the Python 3.11. So let's create this environment here. I will proceed. Okay, let me activate this environment. Okay, so I will use here the VS Code, and I will select the new folder. Okay, so the first thing that you do here, you'll be create the vector store pipeline. Will be a script that you use to get the dataset that we have to generate as a vector store. This is a best practice using LLM applications to be able to separate your dataset, especially to use a retrieval-augmented generation, the RAG. So you can, using the prompt from the LLM, using techniques from the prompt engineer, you just only read the dataset using pandas and get the context. So using this dataset here, and you pass your variable as a dataset, and you will find in this only dataset the recommendations for this product. So this is a kind of way to work as a LLM, but if you have a large dataset, more than, I don't know, 100 products, something that is real big, it's not gonna use, it's not be able to search. Even the chatgpt will deliver for you some errors, specify that you can upload or using as input this threshold from the tokens that you use. So this is a technique to work as a vector store when we generate embed dataset specialized to recognize some kind of keywords. For example, if I would like to search pet friendly or a toy, something related of this kind of keywords on our scenario here, I can use this strategy, because it will be very easy to relate this kind of situation. So we will separate that. You can also use in this prompt, in this script inside the LLM engineer for any execution, for any open question that you receive inside an application. Is just get and do the vector by yourself for any action. So, but this is not that. This is depends on what you have inside your business, because if you have just a catalog from products that will be uploaded once a day, we just can use after we receive this update, I run the vector store, and I don't need it run every day for any execution. So we can separate this vector store just to use as a pipeline. So okay, it's enough to talk. let's start coding. So I will generate a new file here. I will call it build vector star with pi. Let's start importing the pandas. Import pandas, spd. So I will get a data frame with the read csv. I will create a path here, call it documents, and inside your documents I will get the dataset. So this dataset I will leave here in the description of this video. So let's get the dataset here also, and I will get the documents and get the name of the dataset. This dataset is using SAP with dot and comma, and this is it. This SAP, it's inside our data frame here. Click here. So you will enter using the intervals here to get for any product. You will generate a list of this product, and after that generate a document, a structural document from a dataset from the OpenAI. So you will create a list here for index and the row in the F intervals. I will have a content here. We receive a line with the row, product name, right? So we get the product name, category, and price here. Let's put the category. Okay, so let me get a divider here, but inside of my string. So category, I will get the cost price, also the star recommendation, right? So I have the star recommendation here, community recommendation, unless the product description. Okay, close here. So let me see if we have an structure right now. So let me get a print here of the content, and you use run the build vector star .py. I have to install pandas here, so pip install pandas. Let me execute again. It's okay. Yeah, I get so far so good. We have the first interactor here from this new variable. So let's start to create a schema document, because you have to process to embed this kind of the data structure that we have. We'll have to embedding this thing. So to start to embedding, we use the schema from the LangChain. So I will import from LangChain dot schema import document. So let me install the library from LangChain here. Install LangChain. It's okay, so let's return here. So inside of this looping, we will get the docs, the list that we do here, append document. So will be the document from the scheme here that you use. Page content will be the content for any of this structure here, and the metadata will be the SKU or the SKU. The ID from any products that we have inside this data frame. So SKU ID, we receive the row from SKU. It's okay, I'm in the docs here and execute it again, just to be sure that everything's okay. So the content is not defined here. I put the context. I guess that will work right now. Okay, page content. So I put this wrong. Okay, so we have the schema structure already to be able to generate this embed token and also generate the vector star. So we have to use this kind of structure, this kind of schema to be able to use the embeddings here. So as your next move, you'll be create, based on this list, the embeddings we receive from the LangChain all together, OpenAI, import OpenAI embeddings. So you can use here any of these APIs available on the market to generate the embeds from the artificial intelligence. In this case, how it's gonna work? You use you get the power of artificial intelligence to help us develop similarity for keywords for any embed that we have. So this will be responsible to connect if any open question that we receive here. The power of the OpenAI, in this case the OpenAI embeds, to be able to generate the similarity. So we can use from another artificial intelligence. In this tutorial, I will teach for you guys how to use the whole stack of the OpenAI. So after that, we use the chatgpt to get the answer from this application with LLM. So let me install the LangChain OpenAI here. So pip install LangChain OpenAI. On the background of this installation, I will continue here. So we receive the OpenAI embeddings and also an API key. So the API key you will find inside the playground of the OpenAI. So we have to you have to have OpenAI key to be able to use in the embeds, to be able to use the artificial intelligence API, the LLM from the OpenAI. So we have to go to the playground here. And after that, we can go in settings, API keys, and we can generate a new API key for your project here. I will generate one. I will call the Petshop Copilot. Will be the default project. I will not set any permissions. I will create this API key. We'll copy here. Return in our Petshop Copilot. I will create a .env to save our open AI API key, receiver key here, and I will import the OS system to be able to get our .env variables here. So the API key will receive the os.getEnv, the OpenAI API key. Okay, so together with the OS, it's good to everything works well here. Use the .env to be able to update the all .env variables that we have. So this will be useful depending of your environment here. So I will use the load.env and execute the load.env. Yeah, we have our embeds right now. So, and we will use the FAISS index. Will be responsible to work as a vector star for us. So this will be the structure using the OpenAI embeds. Here at the FAISS index to generate these embeds and solving it locally to be able to return this data after. And I will import from LangChain community vector stars. I will import FAISS and also I have to install, so pip install LangChain community. Okay, so we receive the FAISS from documents, docs, the list that we created here, and the embeds to be able to generalize the keywords that we have inside your data set. So if everything goes well, I will get the FAISS index here, save local as FAISS index, and I will print vector star save. Okay, just to be sure if everything goes well here. So let's execute. I will run the vector star. So they ask for me to work if I use right now my machine, because using the FAISS and at the vector star, if I have a large database, it's better to use GPU, right, to be able to compute the whole data set. In my machine, I don't have the GPU available, so I will install the FAISS CPU. Okay, and execute again. And this is it. Everything goes well. We already save your vector star. Let me open here. Inside the Petshop Copilot, we have the FAISS index here with the whole index of your SKUs from each product that we have to be able to return this data right now in your application of LLM. So this is a kind of way to save local, but if you will put application to production, thinking about to use the vector star with a separate NoSQL or structure to be able to get more robust architecture for your LLM application. So this is something that we have to have in mind. But if you use for a proof of concept or a minimal product viable, it's okay to save locally here to be able to return this data. So this is it in this video. In the next video, we will start to work with the agents.